Hi, welcome back. In this video, we are going to be continuing this question on confidence intervals that we looked at before. We have an experiment, and originally we had an experiment of 53 subjects that had 26% had experienced improvement. And we went through this whole process. We did our checking assumptions. We found our sampling distribution model. We calculated our confidence interval and we interpreted it. What we really were concerned with was how large our margin of error was. It was almost 12%. In order for this study to actually be useful, I'd like to get a margin of error that is much smaller. So if we think of this as maybe a first round of our experiment, I now am going to use this to apply for funding to do a study that can be more useful. So what we're looking at here is we are based on the same situation. What sample size would we need in a follow-up study if we want a margin of error of 5% with 98% confidence? We are working with the same problem, so I don't need to check my assumptions and conditions again. I don't need to redefine P. And I'm going to base this off of my original model, or my original sample. Okay, so the first thing that we want to be thinking about is our confidence interval is a point estimate plus or minus a margin of error. And if we look at this margin of error, it's a critical value Z star multiplied by the standard error. So the Z star is affected by my confidence, by this confidence level. So in the original problem, I had 95% confidence, which resulted in a Z star of 1.96, and my sample size. What we're looking at here is setting our confidence level, which will fix this Z star, and our margin of error to calculate N. So there's only three things we can really play around with here. That's our sample size, our confidence, and our margin of error. We don't want to play around with our confidence to change the margin of error. We want to set this based off of our comfort, and then we can try to change our sample size before we collect data to get the margin of error. So this is going to show me, collecting data is expensive. I don't want to collect more data than I need. But I also want to collect enough data that I can get a useful result. Getting a cure rate that's maybe between 14% and 38% is really not helpful. Yes, it works, but something that has an almost 40% cure rate is amazing. And something that has a 14% cure rate is not so amazing. It might not be worth the cost or the side effects. So we want to figure out, well, how much larger of a sample, how many people do I need to include in my study so that I can have a margin of error of 5%. So that'll be a p hat plus or minus 0.05 with 98% confidence. So we can rearrange this formula to solve for N. And when we do, we get this. So my margin of error is Z star times the square root of p hat q hat over N. We are rewriting that to be N is equal to Z star divided by the margin of error squared times p hat q hat. So I currently know my margin of error, they have told me, should be 0.05. And I need a p hat and a q hat. What we're going to do is we are going to use any previous information I have. So in this case, I have an estimate from my first trial, from my first experiment, it was 26%. So I'm going to start with p hat is equal to 0.26 and q hat is equal to 0.74. If I had not done this initial experiment and I had nowhere to start, if p hat is equal to q hat is equal to 0.5, this is conservative, which means we're going to get a larger n. So if you don't know any estimates for p hat and q hat, assume that they're both 0.5 and you'll get a sample size that is conservative and you can work with. So I now know my margin of error, my p hat and my q hat. So I know that. I still need my z star. So let's go back to how we were calculating my z star before. So my confidence level here is 98%. So I want to find that z star. You don't need to draw this. I'm going to draw my work here just so that we're kind of following along with what I'm doing. So z is approximately normal, 0, 1, 0. I have 98% confidence in here. I'm going to have a negative z value and a positive z star value. And the area outside either of these, so 98% plus this is 100%, and these have to be equal. So these are both 0.01 or 1%. So on my calculator, I am going to do inverse norm, 0.01, that's my area to the left, 0, 1. If you have a calculator that will let you do center, you can just put 0.98 as the center, and I'm getting 2.33. So my z star value, put it over here, my z star value is 2.33. Okay, so now I'm going to go back up to this equation here. My sample size n should be that critical value, 2.33, divided by my margin of error, which is 0.05 squared, times 0.26 times 0.74. Now you don't actually have to write all this out because I have my formula written up here as well as all of these individual values written over here. I don't have to do that, but to show you my work. And I get 417.8. We are always going to round this up, because this is really, n should be greater than or equal to that value. So you could think of this as a greater than or equal to this value, because I'm okay with my margin of error ending up being a little bit smaller. That's fine with me. So I need at least 417.8. Even if this had been 417.1, I would round this up to 408. To get a 98% confidence interval estimate of cure rate with a margin of error of 5%, they should use a sample of at least 418 patients. I want you to notice that in all of my answers, I'm making sure that I'm writing a complete sentence that has all of the context in it. This sentence is a standalone sentence. This is what I would deliver to the newspaper if they wanted it, or this is what I'm giving to the committee when I'm applying for funding for my new grant. I'm going to say, in order to get a 98% confidence interval estimate of cure rate with a margin of error of 5%, which is what I need for this to be useful, I need a sample of at least 418 patients, and then I would figure out what that cost was going to be so that I could apply for my funding.